Good morning, everyone. Happy Sunday. This is a bit unusual because it is Sunday and usually I'm there on a Saturday, so I'm already seeing Tom is there, Mike is there. Hi from, you're from Abu Dhabi. Again, that's wonderful. From the observatory. Good to see you all. Well, thank you for joining. And we've had a lot of bad weather, you may have heard, in Australia in the last days. It's been quite bad all over the world, at least in many places. But we just managed to get some images just before the roof closed again today. So definitely a good sign that we can go ahead and welcome to the stream. So you can see that's the live view that we have at the moment from iTelescope, and you can see that the roof is closed. Hi Ed, greeting from Zurich. Very nice, good. Got everyone here. I hope you can hear me loud and clear. So the roof is just closed, but it's fine. We can go ahead. Hi from Michigan. Very good, and hi Rick from Newark. Oh, that's California. Oh, I see. Okay, that's good. Very good to have you all. Thanks for joining and happy Sunday. So we're going to have a rather interesting session this morning. It will take about 30 minutes and we're going to look at two objects. I've just been able to take them and I just wanted to see if I can. Yes, that was the last image that I just took a few minutes ago before the roof closed. Thank goodness I did that. And that's exactly what we're going to talk about today. So let's get going. So today, let's first look at where we are. We seem to live in mediocrity. Our own sun is often described as a rather average star, not too hot and not too cold, not too large and not too small. And our Milky Way, that's our own galaxy where we live in the outer spiral arm somewhere, as we know now, and we've covered that in a recent episode on globular clusters, where astronomers actually figured out where we are in our own galaxy, and we are on a spiral arm. There seems to be hosting a massive black hole. It's also not too big and not too small, and most importantly, it's not very active. Hi Daniel from Germany. Could it be that the combination of mediocrity is the key to life in the universe? Well, that remains to be seen and to be explored for many wonderful years ahead. But today, in contrast to our Milky Way, we are looking at galaxies that are active. So it's very different. And let me explain to you what we mean by an active galaxy. So an active galaxy is something really unusual. They cover about 10% of the galaxies that we know, and they have a very active black hole. So there is a so-called accretion disk. It's really like a spinning disk that you can see there. It's called an accretion disk. Contains a lot of material, and it has a jet that goes perpendicular out. It's more or less like a dipole radiation, and that is emitting a very almost laser-like stream into thousands of light years away. So it is very active. The most active of these galaxies that we know are so-called quasars. Quasars are very distant, very bright objects where the diameter of the whole galaxy, the brightness of the whole galaxy is the same as our solar system, and it is millions times brighter. And that's what we're going to look at today. We're going to look at active galaxies. So before we do that, we have to ask ourselves, what do we really see when we look at other galaxies? Well, if we look at our own Milky Way, and that's what we're going to cover next in the next episode, and we've covered that in episode 1, we have emission nebula. Emission nebula are bright nebula that emit hydrogen and other excited atoms, and we see the lines, and these give these beautiful red colors, and we have them typically in the outer spiral arms of galaxies, and we can also observe these in nearby galaxies as long as we can resolve them. Hi John from where are you from? Sanbornville. Good to have you here. So that is usually what we can see. And then, of course, you see the millions or billions of stars, which, of course, the more distant the galaxy, the less we can resolve. And that is really what gives us the brightness. But our star, of course, our own sun, also emits light. But it has what we call absorption spectra. And then we may cover that one day. So what actually happens is the outer photosphere of the sun absorbs certain lights, certain lines that could be carbon, oxygen, nitrogen, and so on. And we see these these absorption lines in the spectrum. They're sort of dark lines, and they typically appear in many, many stars, except for very, very young stars that are losing so much mass, in fact, that they are emitting typically oxygen, nitrogen, and carbon lines. So those are the only sources that we know. They can be very young stars or they can be emission nebula. The others are just broad spectra and they have absorption lines. What is different with these type of galaxies, and that's the one that we're looking at today, is they have an active nucleus. And this active nucleus is actually emitting lines. That was a big, big surprise for astronomers. So they are emitting lines. You can see them clearly in the spectrum, and they are also, again, typically oxygen, nitrogen, and carbon. But what is different is these are not from stars and they're not from emission nebula. They are from this accretion disk itself. And so how is this actually caused? And this is where it gets really, really interesting. It depends, again, where you're looking from. So as you know, because we have billions of galaxies, we can see them in all different angles spread across the sky. And if we're looking like the eye, they're at a certain angle, you will see the accretion disk rotate at a rapid rate. And that causes, the rapid rate causes the lines to broaden. They broaden because it's called the Doppler effect. It's the same reason why when you stand and you listen to a car that goes, that's the, we all know that sound, and that sound wave is spread out over a wide frequency band. And that similar can happen when we look at a certain angle at a galaxy and the disk is rotating very fast. And in fact, what's happening, those emission lines are most probably caused by interstellar dust that is around the center, the nucleus, the core, where there's a massive, massive black hole. That was this rotating disk that I just showed you. And that is rotating at an incredibly high velocity and causing very, very broad emission lines. But then again, it depends on how you look at things. Because if you look at the side, and that's the next picture here, if you look from the side, you may see something completely different, maybe exactly the same galaxy. But suddenly, the center of the galaxy is obscured by a dust ring. You typically see these very, very strong dust rings in spiral galaxies. And that means we can only see the outer part. And then we see a slowly, slowly rotating disk. And then they become more and more narrow, more and more pronounced emission lines in the way that we used from emission nebula. So it depends on the perspective. So that took astronomers a long time to solve that puzzle. So let's get to our object today. And this is interesting. So this was an earlier image I took of this beautiful side-on galaxy. So that is, let's just go back right in the beginning. So this is called NGC 4945, and it is 11.7 million light years ago. As I mentioned in another episode, astronomers love to study all the close-by galaxies because they can resolve them into stars, into dust planes, and so on. So this is another galaxy that has been very, very well studied, and it is edge-on. As you can see, it's the edge-on. We're seeing it from the side, and it is an active galaxy, which means it has something like this at its core, and we're looking at it from a side angle. So we're looking through the dust layers, and we see the slow rotation of the disk. So rather interesting. So let's jump right back. So that is an image that I got up very early this morning, 2 to 3 hours when the observatory was still open. And you can see a 5-minute exposure clearly reveals the dust the dust lanes very clearly. And let me just jump back to the image that I just took a few minutes ago. That was, by the way, the blue color. I was going to surprise you, and I wanted to show you a beautiful color image, actually. And if you want to, I can actually show you how to do color images. I've actually taken the whole series, but I just won't have enough time to do it here. But maybe if there's interest, I can show you the way to make a color image, and it's not difficult, of this galaxy. Maybe in the next session. So I will take that maybe home as homework. I've taken, and I'll just show you that quickly, what I've done. Let's just jump to, what's this telescope? Let me just see. Run image series. Yes, that's exactly what I've done. So I typed in the coordinate of the galaxy in this case, and it gives me automatically the coordinates. And you can see I took a red, a green, a blue, and a luminance. And then what I do is I superimpose them with software, and within 5 to 10 minutes we can already get a good idea of what the color image looks like. So that's maybe something that I can show you next time. Okay, so let's get back to NGC 4945. So this has a very active nucleus, and as you can see, if you look at this galaxy in the visible, we don't actually see very much. But if you look at it in X-rays or in infrared, and these are typical from all kinds of different sky surveys that are done with large telescopes. We have the X-ray telescopes, we have radio telescopes, and so on. It seems that this galaxy is very active at other wavelengths. And in fact, if you look at it from a radio source, you will find that young stars, and there are a lot of starburst centers, have incredibly strong X-ray emissions and also radio emissions. And that's what astronomers typically study to understand the structure a lot better. And that's also why they know that the center looks the way it does, with this accretion disk causing this sort of laser-like stream, which is caused by the magnetic field of a very fast rotating black hole. Rather interesting. So we never see the black hole, of course, but we see the result of that. So again, this is the so what you can see. Let me just see if I can zoom in a little bit more here. 1 second. See if I can get a better look at this. Okay, now I'm zooming a little bit closer in, so you can clearly see that's an edge-on galaxy. But if we really zoom in more and more, you can see it's not completely at the edge. You can just see that it's got some barred spiral forms, and you can clearly see the dust layers. Okay, so beautifully the way one can resolve this very strong dust layer. But obviously the center of the galaxy is completely covered, and that is why when they look at the spectra, they see these very thin lines. Okay, these very thin lines, as I said before, looking at the side, looking from the side. So rather interesting, and you see that much better in the infrared and in the X-ray region. Okay, so that covers this interesting galaxy. It's called an active galaxy, and they are also called ciphered galaxies, by the way. And it's a type 2. I forgot to mention that. Galaxies with very thin emission lines are called ciphered galaxies type 2. If you look at it from the top, it will be called type 1, which is rather strange because they classify them in different ways, calling them type 1 and type 2 according to whether they see broad emission lines, or if you look at it from the side, you see narrow emission lines. Good morning from Birmingham, Mike. Good to have you here. Good morning. I'm bombarding you all with all this rather scientific material. I hope you'll be okay. So let's go to the next object. And it was lucky. It was just when the observatory was open. That is a globular cluster that I wanted to show you. And here it is. That is a globular cluster. We covered globular clusters when we covered Omega Centauri. You remember Omega Centauri? I had this incredible magnificent globular cluster that consists of very, very old stars in a recent episode. If you've missed it, look it up. We're talking about globular clusters. And what's so interesting about globular clusters is it actually revealed to us where the center of our galaxy is, because what a very famous astronomer noticed is when you map out where these globular clusters are in our own galaxy, if you map that out very clearly, you get this type of pattern, right? That you can see there. And if you match this pattern, they assumed that the globular clusters, for some reason, must always be around the central halo of a galaxy. That's what they observed. And when he took that deduction, he actually could deduce where we're sitting. We're sitting right outside on a spiral arm. So by just observing globular clusters and knowing they're the oldest objects and where they're located, observing other galaxies and so on, the deduction was we must be sitting outside, and we're certainly not in the center of our own Milky Way. Quite important. So that was the significance of globular clusters. So what is the significance of the globular cluster that we are looking at today? And I'm just going to show you a picture that I just did a few minutes ago, just before the roof closed. There you go. So that is the globular cluster called NGC 6973, which is quite close. It's about 7,200 light years from Earth, making it one of the nearest globular clusters that we actually have. And it's not as big as Omega Centauri that we had before, but it still consists of 400,000 stars. What's interesting about this is it has undergone a core collapse. A core collapse basically means it shrunk into something that is quite dense. And you may recall this very, very interesting picture that I found some episodes ago. What is it like if we lived in the center of such a globular cluster? What would it look like? And it would look extremely bright. I mean, we would have stars that would outshine our moon by several magnitudes. And we would actually never be able to look outside the globular cluster if it is as dense as the one that we're discussing now. So that is the conclusion of some astronomers who calculated this. They made this picture, and it would be our night sky would nearly look the same as daytime. That's how bright it would be. So anyway, we don't live in a globular cluster. We can observe them. And what is interesting just about this object is that in 2004, this globular cluster was looked at by some astronomers, and they actually were able to date the age of this globular cluster to about 13.6 billion years. 13.6 billion years. How do they know? Well, they look at the spectra, that is the light that comes from the individual stars, and they found that they're very, very similar. And by looking at the beryllium content of these stars, they are actually able to tell the age with some calculations and so on. They are able to tell the age of these stars, and they're extremely old, much older than our own galaxy, which is of course interesting. It's the question, why do galaxies have globular clusters, and how come that the globular clusters are much older than our own galaxy? Questions that current research is working on. Okay, my friends, I hope this was interesting for you. I wanted to show you this live, but I wasn't able to do that today. But I still hope that this short episode was interesting. What I will do next time, and I'm just going to show you that again, is, let's see, the roof is still closed. Still, we managed to do the objects. Is I took the galaxy in red, green, blue, and luminance, and I will see if I can make a simple color composite, because that's about 20 minutes of exposure. You can make a very simple color composite, and maybe next time I can show you the color composite and how to do color composites. By the way, next Saturday will be extremely interesting, because what we'll be looking at next Saturday is I was talking about what really emits in our own galaxy. Those are emission nebula, and those are very, very young stars. Those are really the objects that emit. a lot of light. And we're looking at the most beautiful ones that are actually very close to the galactic center. The one is called the Trifid or Trifid Nebula, and the next one is called the Lagoon Nebula. And we'll be looking at that in the next episode. So then I hope you'll join me. Mike has a question. 1 second. Do you know if there's a higher incidence of binary systems in globular clusters? Ah, that's interesting. You know, if there's a higher incidence of binary systems in globular clusters, that is, yes, yes. Oh, has the stream stopped? Sorry, has the stream stopped? The stream should not have stopped. Let me just check. Are we still live? Stream was interrupted. Not sure what happened there. Okay, I think we are back. I'm sorry, the stream must have stopped for a moment. Let me just write, are we back? Sorry about that. I don't know what happened there. Are we back? Yes, we're back again. Sorry about that. My apologies. Yeah, we're back. Not quite sure what happened there. Sometimes we're, yeah, stream seems to be good again. My apologies. But let's get back to the question. The question was because a globular cluster has binary star systems are quite common. And the question is, would a globular star system have binary systems? That's a very clever question, actually. It's more than we would find them usually, right? That's a question from Mike. And the answer is, I will look that up. I don't know. And that's a very, very good question. So I'm writing this down as my homework. Hi, Daniel. Yes, we are back now. Sorry about that. Don't know what happened there. But I'm going to look that up. I really love these type of questions because binary systems, as you correctly say, are very, very normal. You know, 2-star systems are very, very common. Dietrich, yes, it's okay now. Good. So I will look up what the binary systems in globular clusters are. That's a great question. Okay, I'll take that home as my homework. Okay. Are there any other questions? So we're back. We're still live. Yes, we are. Okay, good. So what I want to do for next, so just in case you missed that, next week we're going to do the Trifid Nebula. We're going to do the Lagoon Nebula. Those are so beautiful, emission and reflection nebula. We're going to. I will see if I can give you a color composite of NGC 4945. And I will also look into the question here from Mike about the binary system. Okay, I think that those are all very good questions, and I'm absolutely delighted when you ask those questions, especially when you stun me. I like to be stunned, and that's what it's all about. That makes it far, far more interesting. So anyway, my friends, thank you so much for joining me. I hope you enjoyed it, and sorry that the roof is closed, but that is beyond our control. It's just the way it is. So it's certainly interesting. I mean, the topic of active nuclei and active galaxies is very interesting, and what interests me, of course, would it be possible to have life in active galaxies when you're bombarded with X-rays and so on? I don't know the answer. Maybe one day we'll find out. Okay, well then have a wonderful Sunday still. Greetings from Washington, Bruce. Yes, and thank you. Thanks all of you for joining. If you have any requests, write to me, please. Write to me. If there are any special requests, questions, I will look into that, and we will always do the best to make it interesting for all of you. Okay? So having said that, I will just type, have a lovely Sunday. There we go. And so I wish you all the best, and see you next Saturday. Thank you.